Yeah, you just give me a go whenever I shall start.
Okay.
So welcome everyone to tonight's session. We're really happy to have Annika Klaas here from Amsterdam in the Netherlands, and she's received her master's in 2020 and is working in the fashion industry now, and has won a lot of awards, including an Adidas Fellowship and several other awards. So we're really happy to have her to see her point of view of knitting. Welcome, Annika.
Yes,
Welcome.
thank you. Thank you for the introduction. Can I just share my screen quickly?
Yes, please.
Okay. So, okay. So yeah, I'm Annika. I quickly introduced myself. I work as a knitwear designer and developer, programmer, and researcher. And I do so.
Annika, I think we might not be seeing the right screen because it's all black.
Oh, okay.
We're supposed to be looking at an all black screen.
So then I maybe just show it in the Acrobat view and not the.
Yeah, okay. Because I think, yeah, we're supposed to be seeing this, not just plain black.
Yes. But now you can see the.
Yes.
Yeah, perfect.
Yes.
And yeah, I work at Knitwear Lab in the Netherlands. It's a research and development center for different knitwear applications. So we work with fashion customers, but also with researchers or with customers from the shoe industry, a lot from also innovative like 3D projects, like bra projects, for example. And I got to get into the programming side of knitting as I started out as a designer and wanted to know just a lot more about what is possible. And I realized I can only do so when I also program my own knitting, and then I can dive really deep into and design a lot more. So that's where I got really hooked up with the programming and developing side. And that's what I mostly do on a daily basis now. So programming knitwear. And to show you quite a range of application, I quickly scroll through these different pictures from different companies and from Knitwear Lab. And you can have a quick look of all the applications there are for knitwear. And I get the question a lot why knitwear is so increasingly found in so many applications. Because a few years back, it was basically all in the fashion industry. And with every year, there are coming more industries discovering knitwear for their own applications. And I think that has several reasons. For once, it has a lot of advantages compared to other textile production methods. It is very flexible, so you can knit like a one-on-one. You don't need a big production. You can basically set up the machine very fast. So what you're discovering now as well is that you can just knit your samples and don't have to have a huge production. Is like if you have to prepare a warp for weaving, that is a lot of effort. You basically need to take a lot of meters from the weaving and can't do that much experiments on that. So with flat knitting especially, you're very flexible. And one of the most advantages, I would say, for me is that you can combine different zones in one material. So you can have for example, different stitches next to each other, one very elastic stitch next to a very stiff and sturdy stitch. You can have different materials next to each other, so different yarns, and basically wool next to polyester, or some melting yarn next to a cotton, and achieve through that very different characteristics in only one material. And that gives a lot of possibilities, even if you don't want to have seams in there. So because of aesthetics, or because it's faster to not have seams in there, or because the seam in fashion applications, for example, it would be itching at a certain point. And that leads to the next point, the limited processing afterwards. So because you don't have to have that many seams in there, you have less processing. If you have a normal fabric that you would buy, first fabricate on machine, that you would have to cut first and then sew it, and have all these processing steps in between. And with knitting, you can eliminate most of them. So you're way faster to the market, but also you are more flexible again. And the next is that you can incorporate shape and 3D knitting. With most other productions, you're producing something flat. And in knitting, you can have a certain shape in it. I'm sure you're all experimenting with that already in the workshop. And not only can you have basically more rows added in a certain point to achieve some kind of 3D bubble, for example, in a flat environment of the fabric, but you can also knit in shape, knitting fully fashion, which means you can narrow and widen a knit to have not a rectangular fabric afterwards, but the one that has the specifics of your application that you need. And that is eliminating a lot of waste. So in normal, in fashion, you have a lot of cuttings that you have to throw away. So if you have a certain pattern that has a weird shape, you need to cut it out, and then you have a lot of leftover fabric that you can't do anything with, that goes to landfill. Sometimes that's even up to 30%. And through knitting in shape, you're eliminating that. So you're only knitting what you actually need. And then knitting just has a high possibility for customization and digitalization. So also what you're working with right now, so having a file that you can always forward to a technician that just puts the color arrangements on top and knits it then, it just gives you a whole lot of flexibility, because you can change your file all the time without having the technician to change a lot and spend a lot of his working time. So it's cheaper and quicker, and offers also some on-demand production or customization, like having a different pattern on the product that you're knitting. And what I like a lot about knitwear, or what astonishes me a lot, is that there are basically only 3 different elements. And with these 3 different elements, you can, you have endless possibilities, basically. You can fabricate all these different stitches in these different applications I showed you earlier, with only these 3 basic elements. You have a stitch, a tuck, and a float. A stitch I'm sure you all know and you're working a lot with already. A tuck is basically laying in the yarn but not pulling it through the previous loop. So this is creating this not complete loop and stretching the loop that is underneath, and it does widen the fabric a bit. So these feet of the tuck basically stretching the knit outwards in that direction. So it affects your dimensions a bit. And then you have a float, which is basically really not knitting. So the yarn is not laying in the needle hook. It just passes by. And that gives stiffness to a knit because it locks. Normally you would have all this length of a loop to stretch when you pull from these two sides. And that gives knitwear a lot of elasticity. And when you have floats, you can't stretch them more than they already are. And that locks the fabric. So with that, you can create a stiffer application. And also you can create a bit of a woven look with it, as this resembles like a float in a woven fabric. But you can't float for, let's say longer than an inch, because otherwise it gets stuck in the needle head. So there are certain restrictions. And I was talking about it, that you basically with these three elements can create a lot of different swatches and different stitches. So these are just a few of the very basic knitted structures that you can create. I'm sure you know most of them. You know the single jersey, which is basically if you have a simple pullover, that's mostly a single jersey. It's knitted on a single bed, and then the double jersey is knitting on the double bed, so using the back bed as well, and it's a lot more elastic. Then you have ribs, which are also a lot more elastic. I'm not going to go into all of them. The tubular, I think you're using as well if you're having the joints of the glass fiber. So I think you might be sticking them through a kind of a tunnel. And that is what a tubular basically is. So knitting without a connection in between on the front and the back needle bed. With the azure, for example, you're using the transfer. So you're transferring one stitch to the next needle, and there you can create a hole. And that's also the same way you can create a narrowing, so transferring from the sides inwards. There are cables, so basically changing two positions of loops. So the two loops that have been here previously switch to that side. You can knit multi-gauge. There you need special machines for. That basically means you can knit several gauges on one single machine. So each machine has their specific gauge, meaning it can knit finer or coarser. But there are machines that have a bit of a bigger needle hook on a finer machine, and there it can knit also coarser yarns. And how this swatch is created is basically there are knitting with a 230 Marina Wool yarn on every needle on the front bed in this part. And maybe we can also zoom in, then it gets a bit clearer. And then knitting with 3 plies of the same merino wool on every second needle in here. And there you just get a lot of a coarser knit. That is interesting for aesthetical reasons, but also if you want to combine different yarns with different parameters in one knit. And also you have the flexibility of covering several gauges with the same machine. Then there are the different jacquard types. There you can basically knit with 2 different yarns at once and create patterns. You can have different graphics for different colored yarns, but you can also combine different materials that way. Basically, in a jacquard, the color that you see in the front is always knitting in the front, but is taking with it in the back as well. So the green is basically knitting all the way here on the back, while the gray is knitting on the front, and here it changes. And there are different ways to bind in the other color in the back. So this is where these different jacquards are used. In Taja, you can basically knit with different yarn carriers next to each other. So here the green is not taken in the back. So you can see it also affects the color a bit. So this looks a lot greener where the green is knitting in the back. But here it's knitting the gray until here, and then it turns around and knits back to here. And then it only starts knitting with the green here. And for knitting with the gray here again, you basically need a new yarn carrier. So then you have yarn carrier on that side as well, and it's coming in from here and stops here as well. And Intaja is great also for different applications. If you want to knit with sensoric yarns, for example, and you need the yarns to not touch, that is great because you can separate them by an Intaja. And yeah, but it requires a lot of more yarn feeders. And some of the yarn, or some of the machines are quite limited with yarn feeders. Most of them have 16 in total, so you can't do a whole lot of pattern in there. There are some machines with 32 yarn feeders. There you're way more flexible. And then there's also the plating. The plating is very interesting because you can knit with 2 yarns without having to use the back. And how it works is basically you in this case, this is basically a single jersey plated, so you only knit on the front bed, and you're knitting with 2 yarn feeders, but simultaneously. So if you watch my fingers, one is the one yarn carrier and the other one is the other yarn carrier. So one is green and one is gray. And you knit with them at the same time. They both lay the yarn in the needle hook. And you can say in a specific place, okay, we change the position, and the other one is in the front. So the green now knits in the front and the gray in the back. And then knit a bit and then change it again. So this is interesting also for creating patterns. You always have a bit of a change, and it creates kind of this ikat kind of look. But you can also have that for only knitting 1 yarn feeder on the front and 1 on the back. For example, having a wool yarn on the outside of your knit and a silk yarn on the inside of your knit, so it feels very soft to your skin and you don't get any itches, for example, from the wool, but still having the warmth of wool. So quickly zoom out again. So all of these swatches that you can see here are basically the same dimensions. So all of them in the program equal 100 stitches in width and 100 rows in length. But you can see that they come out quite different in size. So what is really important to the knitting is the stitch dimensions of a specific structure. Whenever you knit something, you normally first do a swatch in your specific yarn and your specific stitch, and then count the stitches on there to see how they perform. So the ribs pull a lot more together in width, and the cardigans, which are composed with tucks, they stretch a bit in width. And for example, a tubular always knits one one row on the front and one row on the back to create one row completed in height. And that is why a tubular out of 50 stitches in height is 100 stitches in height equals basically 50 stitches in height of a single jersey, because it's half the amount of rows. So whenever you knit, for example, a tubular next to a rib, you need to be aware that you either need to add stitches in height to the tubular to get the same amount, or that if you add a rib on top of a tubular or beneath the tubular, that it will pull it together. And you can make use of that. Similar, I mean, the most known example is I get a pullover with a rib sleeve, and it kind of clings to your arm and you can pull it up, and it has kind of a specific missing word. It's basically useful for the knit to give you the properties, and you can also use it shape-wise. So if you want something to stretch, or if you want a rib to stretch in a certain place, you can use that. Next is yarns. Yarns really changed the knitting a lot. And there are so many materials and yarns that you can knit with. I think there's no one in the world who knows everything about what even is possible. I gathered just a few examples. For example, there's filler yarn, which is a yarn that you can knit between two layers as a float, and after steaming it kind of explodes and gets thicker. I have an example of the ones I previously showed you. For example, in here, in this padding structure, it is knitted with the black as a front layer, and I assume the gray as a back layer in here, only knitting on the back bed. And in between, there is running the filler yarn as a float. And that just expands afterwards and creates this kind of cushioning here. Or in this one as well. So this one is in a seat to have some cushioning for the seat structure. And what we also have is the monofilament, for example. We just saw an example also of that. The monofilament is very stiff and it can create some kind of a spacer material. So how this knit is done, quite similar to the cushioning sample we saw previously. The black one is knitting only on the front bed, and it's a black elastic that pulls together. And the white bed is only knitting on the back bed, and it's also an elastic. And in between, there is the monofilament tucking. So it once tucks in here, and then it follows until here and tucks in here again. So you have kind of a zigzag created with the monofilament. And once it's steamed and coming out of the machine, the elastic pulls together, and what has been basically laying before, so before the stitches pulled together, it looked more like a flat zigzag. It pulls up, and the stiff monofilament acts also like this kind of a sponge or squishy element, and it's very stable. So this is also used, for example, in car seats, and they use it for putting the heat, the seat heating cables through that, and having that space, to basically heat up. So we already talked about elastic, for example, with the monofilament, that it pulls so much together. This is a very thin elastic. It's almost not seeable. I use this one a lot if I want to give another material more elasticity. So if I want a very stretchy wool fabric and that is more compressed but still has all the properties of wool, I would take wool and plate it together with elastic on the back. So you don't see the elastic, but it gives you this compressing effect. Then there are different technical yarns, for example, copper. It's not really a yarn, it's more like a material that has a yarn-like appearance that you can knit with. Another technical yarn is, for example, this Sensoric Yarn. This is a glove that is knitted with this Sensoric Yarn, and when you put it on, you can actually use it to move a robotic arm in another room. So basically, with all the movements you're doing in here, it measures it and sends it to a robotic arm to do some, or to do the movements that you're doing. And one that is also very interesting is melting yarn. Melting yarn is also not really a yarn in itself. It acts more as a glue, and you never use it on its own. You normally use it with a different material and also plate it with it or just run it with it. And what it does is, once it's knitted, you can steam it, and after steaming, it melts away. And through the heat, it acts as kind of a glue and stiffens up the other material that you knitted it with. So it really gets soaked up and dissolves into the other material. And after like 2 hours of cooling down, it gets a really stiff and rigid knit out of it. So this is also something that might be interesting. I know you had the lecture yesterday with Marina, and because for casting with concrete, you need something very, very stiff and that is not too elastic and doesn't sag. And this melting yarn actually provides that stiffness to a knit. And I quickly want to also cover challenges in knitting that I am seeing right now. What I'm a lot of concerned with on a daily basis is the knitting time, because knitting, especially flatbed knitting, to a lot of other production methods is quite slow, and knitting is paid by the minute normally. So whenever you have a program and it runs a long time, you're paying money for it, and there are lots of ways to make your knitting program more effective. So it knits faster, and you save basically costs and time on the knitting machine. And there are a few ways that I always incorporate. So one is having in mind how many systems your machines have. So a system on a knitting machine is basically the area where it creates the stitches in the cam. And most of the knitting machines have either 2 or 3 systems. And that means you can, for example, run 2 or 3 yarns at the same time and create 2 or 3 rows at the same time. But you can also use the system like knitting in system number 1 and creating the stitches, and using the system number 2 to do a transfer to create a jour, for example. And whenever you have in mind how many systems your machine has, you can create a much faster knitting programs, because then you can take full care of the system run, basically. What also is very difficult, or what needs a lot of research for advanced projects, is finding really the best fitting materials, because there are so many materials that most of I'm sure that I don't even know of. You can have custom made materials, so whenever you want for example, very specific yarn that should be elastic but should be very cheap at the same time and should have that certain rigidness, you can always have basically a core from elastic and then wind it with a polyester that has your specifications. So you can have custom made yarns for that. And finding what is possible in there and what fits your project best is very, very important to the outcome of the knitting, because the materials do affect the knitted outcome so much. So also if we go back to the swatches, these are all knitted of 230 Merino wool, in most of them in one ply. But if you would exchange that now and knit it with an elastic, they would change completely in size. They would change in their characteristics as well. And you basically have a whole new material. And what I also find a challenge, especially in fashion, is keeping up with all the possibilities that there are, because especially in the knitwear, there are so many possibilities regarding the digitalization, also the way you work right now. But most of how it is working in fashion, they work very old school and are not pushing the boundaries. So it's actually very nice that a lot of other industries come and work with knitwear as well, because they are pushing the boundaries of knitwear and what can be done. Because I think there are also still so many new things, how to work with the machines and what to get out of there, that there's just so much room for new developments. And I want to show you quickly some things that I have worked on. This is one hat I was working on at Knitwear Lab, and this is to show you how it is possible to shape things on a machine and how to use specific machine specifications. So this hat is, or if you would imagine to knit it by hand with 2 needles, normal to knit a hat or a beanie would be to start at the bottom and then going up and narrow at the top. But this is basically knitted by short rowing. I'm sure you have covered that as well. And this basically means you're working in these kind of triangles in this hat. So you see basically here you have a certain angle you're knitting with, then here's the next one, here's a certain folding line, and that's a different angle. And you're coming from here and knitting all the way till here, turning around, but then not knitting towards the whole edge, but stopping here, turning around, and then stopping a bit earlier, and doing so until you reach that whole triangle, and then doing it again. And the hat is composed of 12 of these elements. But what is specific is that in the end, you really have only very little stitches that hang here on the needle pad. So having 12 elements here, on this side is only always 2 stitches knitting. So here are basically in total 24 stitches. But on this side, you have 1,800 stitches. So this is a lot of difference. And in the knitting machine, you always need something to take the knit down. I don't know if you have experience also with domestic machines. There you normally have like a comb that you hang in and that pulls down the knitwear. But the comb pulls very evenly. So if I would put a comb on here and then pull with the same speed on that side and on that side, these stitches would break immediately, and those stitches would bubble up over the needle bed and would create a whole mess. What you can do, or what machine is used for this one, is a specific takedown. It's a belt takedown, and there you don't have a comb that pulls down evenly, but you have two rollers that sit very close to the needle bed, and they catch the fabric immediately that comes down. So there are two rollers always rolling in this direction and catch the fabric that comes down. But it only pulls in the places where it's actually needed. So it doesn't pull much here, it only pulls on that side. And that enables it to create that shape. And I also wanted to show you that because of the shape of the head, because you can see here it's quite flat, you can stretch it out completely. But once it's sewn together in this line and put over a head mold and steamed, it gets this shape. And this is because it's knitted with the melting yarn that I mentioned earlier. So the melting yarn melts and just keeps the shape of the mold that it is put on and left on for an hour. And afterwards, you can basically take the hair, you can also squeeze it into your suitcase and then take it out again, but it still remains in that shape. That is what you can do with materials. Then here's some research swatches I did with weave-in, and the weave-in is basically composed of different floats. So it resembles a lot a woven fabric. Here are the floats that go, for example, here over 3 stitches and then go to the back and come to the front again. And the actual stitches of the knit serves as kind of a warp. And with that floats, as I said earlier, you can lock a fabric very well, so it gets stiffer. And also here with materials, I used this kind of a paper yarn with a specific coating, so it's very stiff in itself and has melting yarn in the warp. So this creates a very stiff fabric that can be used in a bag, for example. But using the same technique, but in a very soft yarn, it creates really the softness of a woven fabric that is very coarse. And then you can combine it with all the other advantages of knitwear. So basically here in the background, it's also plated, so you can change color there. You can knit it in a specific shape. You can add folding lines, and that all in one single piece. And that wouldn't be able in the woven, even though it kind of resembles now a woven piece, and you still have the aesthetics of it. And here I was more researching into layered knits. For example, this swatch over here, I was interested in how different materials overlay each other. The front is knitted on the front bed, and it's a silk material, and it's knitted very loose and creates this see-through fabric. And I wanted to get a pattern on the back, even though it is the back stitch where you only see the inside of through the front stitch, basically. And I used the float jacquard and used basically only the floats of the float jacquard to create this pattern in the background. And then here I was using a very thick material on the inside to create like a warm layer. and have very soft layer to the skin and a very shiny viscose on the outside. And this is basically also done in multi-gauge, so knitting every second needle on the inside, but knitting every needle on the outside. And so combining these two quite opposite materials. Here I was researching into how shaping also affect the aesthetics and how you can actually use it as kind of a design line. So this shape is created by goring the swatch here, and it creates this kind of design line in the pattern itself. And also like closing elements become part of the knit. So here, what you can see here is this tubular knit. It's a little pocket knitted in. And then I programmed a machine stop in the machine, and it stopped while this little pocket was still open. And I used a magnet and put it in between the two needle beds in that pocket and started the machine again, and then it closes that pocket immediately, so you won't see it afterwards and can't take it out. It's safely secured inside. And I was also testing like how to use the same stitches in different applications. Specifically in footwear. So this was originally a swatch I developed for fashion and for garments. And then I used it with different materials to develop footwear out of it. And that was what I developed in the residency at Adidas. And here I also chose a combination of materials. It has wool on the inside that gives a very soft feeling, and it absorbs the moisture, but it has recycled polyester on the outside, which gives more of a strength and rigidness to it. And there you can see other shoes that I worked on with that methods that I realized during the creative residency at Adidas. And there you can see one example of also these structures that are normally used in fashion applications. So this pleated structure and how to use it in a shoe and how to make it rigid enough to also work in a shoe. These are also swatches researching how to develop different shapes on a knit, and this is created with adding different folding lines in the knitting. How you do that is whenever you have a bit of a thinner structure in one line, it automatically breaks in that structure, and you can create mountain folds and what's the opposite of mountain? Well, the opposite fold of the mountain fold, and can create very specific patterns in there. And this I used, for example, in a bag, because also these structures give a lot of strength. You can easily imagine that, for example, if you see a paper, basically can't really hold it on its own. But as soon as you start to give it a pleated structure, it stands way more easily. And it can also hold a lot more. So this pleated structure is used in here also to expand the bag. And I'm sure there are also quite some application in architecture for using these pleated structures and folds to have more rigidness and more stability to your fabric. And one last example I want to show you is that is a collection I worked on where I tried to set up the knitting machine in a way that I could always produce everything on demand. So all the yarns that I used have their specific place on the knitting machine. It was a knitting machine with 32 yarn feeders. So I used all of these yarn feeders with a specific yarn, and all of the collection items and the programs were set up that it could automatically pick the yarn feeders that it is assigned to. And the whole collection was programmed that it doesn't need any processing afterwards. So it basically came out ready out of the machine. All the closures were knitted in and all pockets were knitted in, openings and everything. So it had basically no processing afterwards. And I didn't do, so basically you could do them seamless. So seamless meaning for pullover, for example, you're knitting 3 tubes, knitting a tube for the bottom and the body, knitting 2 tubes for the sleeves, and then combining them with like that it is only 1 tube at the top again. But this gives you quite some limitations, because when doing so, you're basically knitting always on the front for the front bed and on the back for the back bed, but you are limited in the interaction of the needle beds. Because you always, when you want to do a back stitch for the front, you need to have a free needle on the front, otherwise they would interlock and it wouldn't be a pullover anymore, but like a flat piece stitched together. And because this is quite limiting in the structures you can do, I programmed most of the pieces that they just, through the cutting and the structures that were used, would still be finished after coming out. And also, for example, in here, I used the rib next to a rigid structure that would pull together and open for the hole for the neckline. So this is basically the same amount of stitches here and here, but here they just pull together a lot through the structure. And I think it's always nice to take the specific properties of a knit and use it in the way to achieve what you want to achieve in shape. And yeah, so basically all of these items were constructed in such a way that they come out finished out of the machine and make basically an on-demand production possible, because it doesn't take much time to change yarns on the machine, to put on the order. Yes, that was input from my side. I'm very happy to answer any questions from you.
Great, wonderful. I think that it's so interesting to see this different approach, because you're working so much with the detail of the material and really like these sort of thoughts on how it can relate to the body, right? Because of the different textures that you can create, as well as different structures, really define how the material reacts at that kind of small scale. And I think that this is where architecture is kind of bad sometimes at invention, because we tend to steal from a lot of other fields, right? It's like modernism came from art first, like modern art was before modern architecture, and like we're always learning from other fields, which is something that with using these kind of knit textiles is definitely, we're learning a lot from other fields like fashion and industry to be able to adapt these to architectural purposes. I do have like a question though, is what kind of machine are you using? Are you using a stole machine, or are you using a Shimseki, or?
So I'm a programmer for Stahl machines, so I know the basics for the Shima, but I'm not a technician for Shima. So I work with Stahl machines at Knitwear Lab. We do have 2 ADF machines and 1 CMS, and expanding to 2 more ADF machines right now in the variants of gauges. I do like the bit finer gauges, I have to say, because you have to, you can just create a lot of fine details with it and do very technical textiles. So yeah, we're getting a 18 gauge ADF, which I'm very much looking forward to.
Great. Are there any questions from the students? I know I jumped right in because I was curious about that, but we want to make sure the students get their questions answered. Yes.
I have a question. I thank you for sharing the whole process, and it's very, very deep. It's too deep for me, so that I couldn't understand too much details. But I will watch the record to understand as much as I could. And my question is very basic. Which is the most impressive material you have used? Since we are all confused about that much of material and trying to find all the possibility. So I want to know which is the most impressive material for you and why, and what's the example for that?
Yeah, I think where I come from a fashion background, so that is different for architecture, I guess. But I think I have to name Marina Wool. I mean, it's very basic, but it is just an incredible fiber with so many good properties. So it's basically moisture absorbing, but it never feels wet. You can wear it for days and basically not really sweat in it. It is very warm in the winter, but it is cooling down in the summer. It knits very well, which is nice because a lot of different materials, some do not work great in the knitting machine. So knitting with copper sometimes works, but sometimes doesn't. For example, copper really has somehow its own its own way of working. There are some meters on the cone that work well, and then there are coming some that just always break. But Merino wool just always knits very nicely on the machine. It has this kind of elasticity that it also shrinks nicely after steaming to create a very clean surface. Yeah, I think I would have to name Merino wool.
Okay, thank you so much.
You're welcome. And
any other questions?
Thank you for your presentation. I just have a very quick question because I also have a fashion background, and I'm wondering, because I know that most fashion students have no idea about this because they're like specialized masters for knitting, but I was wondering, how did you get into this very sort of technical knitwear? Because I know that most designers don't really care to deal with the technical parts, and I'm just interested because it's quite cool.
So I started out studying in Reutlingen, and Reutlingen is basically the city where Stoll is based, and our university gets sponsored from Stoll, and we have 5 knitting machines. So this was the starting point that I had access to the machines, and I quickly got intrigued by what you can do with the machines. Firstly, I was using the hand knitting machines, but then seeing what possibilities you actually have with the CMS and ADF machines from Stoll. I quickly got into programming and seeing what is possible. And seeing what is possible, I always wanted to dive deeper into, because there's so more possibilities. And I think I've been now programming for 5.5 years, but there is still so much that I don't know about the machines or knitwear, that I think you can basically keep on learning about it for your whole life. So there's so many possibilities, which I find very interesting.
All right, thank you.
And I wanted to add to see you, whenever you have any questions, also when watching it afterwards again, you can always also write me an email and ask if you have a specific question.
Thank you, Annika.
You're welcome.
Very, very nice of you. And also from your lecture, I found a lot of very solid, fundamental, useful knowledge for us. Even though architecture students may feel a little bit strange to our knowledge, but when we are diving into this knit work, especially developing new products based on knitting techniques, it's quite useful because we don't have that background of knowledge, especially when choosing the yarns. We have totally no choice what material we can knit.
Yeah.
And also, I have a very strong feeling that you mentioned, and not only you, but also Marina mentioned, maybe for fashion industry, knitting is a very slow manufacture process compared with other fabric manufacture process. Yeah. But in architecture, it's, in this workshop, one of not our group, they knit fabric formwork for a bridge, just within 1 week from design to fabrication. But for normal formwork, like made of wood or other rigid material, it may take a month. So maybe in your industry, knitting is kind of slow because it has so many variations and maybe the production rate is slow. But when put into other industry, the speed is already amazing, I think.
Yeah.
Yeah. It's nice to hear to also see what we can get out of each other's industries, because I have the feeling that it is so nice that other industries are pushing into knitwear because they are pushing the digitalization in knitwear.
Yeah.
And that is something really the fashion industry doesn't really dive into, because they're working very individualized on every project. And I think that's, a huge advantage of your industry coming into knitwear.
Yeah, we have higher demand on the 3D shaping, especially for arbitrary shapes. We want knitting to be as like soft 3D printing. So we're kind of trying to make knitting into 3D printing. Looking forward for cooperations between like you guys, you talents from fashion industry and our student from the architecture background. Really looking forward to the result.
Yeah, I think both can really learn a lot from each other. Yeah, thank you a lot for having me. And
Could I ask another question?
Yes, sure.
I'm sorry. I'm just wondering, now the fashion industry have to face the recycling issue because now it's a global topic. So I'm wondering if there any new material could need the recycling need, and also with like the 3D shape. For knitting, is there any possibility material, or it's under the test? Is there any new material?
Well, it goes in kind of two directions, because one is using synthetic fibers like polyester or TPU that you can actually recycle afterwards. And so having it all done in a mono material that you can afterwards easily recycle. But it's always a down cycle kind of, because whenever an item gets worn, like basically, for example, a shoe gets worn over 1 or 2 years, and then you take the upper and make it into a new shoe, it is, you can basically not use 100% of that material to do a new shoe. You always need some virgin material because the material is kind of worn out. And the other side is using only natural fibers that are more biodegradable, or that are biodegradable, let's put it that way. And those, there is no really good way to recycle them. The only really good way I see is the lyocell tencel that you can, basically there you can use an old t-shirt made of cotton and put it into a solution and then spin new yarn out of it. But other than that, it's all mechanical recycling, and there the fibers get shortened a lot and you can't do really high quality clothing of it afterwards. But in my opinion, the biodegradable makes actually more sense because we're creating so much synthetics and plastics right now that we just can't recycle it all. I mean, there are enough plastic bottles and plastic waste that we can use instead of recycling our old shoes, which is also a lot of effort to take the upper part, take everything, and then recycle it. So it's very, it's not very cost efficient right now.
Okay, thank you. Thank you so much.
You're welcome.
Great question, though. Any other questions? All right. Well, if there are no more questions, thank you so much, Annika. We really appreciate your lecture and your thoughts on all this. So thank you so much. Hopefully you can see some of our results online and things like that. We'll definitely send them to you. So
yes, that would be great. Also, like seeing what is the outcome.
Yeah,
really interested. Yes.
Thank you, Virginia. Thank you, Annika, and thank you for everyone who has come into the meeting. Yeah.
Thank you.
It's so nice.